Welcome back to class. So last time we talked about how we do some calibration of cameras and different color spaces. Today what we're going to talk about is how we can actually do object detection using just colors and also edge detection to find edges and corners in images. So the first thing that we'll talk about is just color detection. And there's a video I'm linking to in this class that and an article that describes more of these details. So make sure you check that out. But basically, what we can do to do color detection is basically we can do thresholds on the color. And when I say on the color, we're typically going to use H, so the hue, and make this a tight value where we're just looking at a little bit of the threshold of, so a narrow range in hue, but then we're going to let the saturation and value span a wider range. And what this lets us do is basically adjust for lighting and other factors better. Okay, so the basic thing here, and then you'll read more about this in the link I've given you, is that when you do these thresholds, you might have some image, and you're going to have some areas of red that you're trying to find. Well, when you find all of these areas of red, ideally you may have found one very large area of red and you label that all as red, but it may be that you have these small little groups that are tightly clustered together, and what you want to do is actually connect them together. And this is this connected components algorithm that you'll read about online. So this is a very common technique in basic computer vision to actually identify blobs of color, and we'll be doing this a little bit in the upcoming homework to actually use some basic processing to find color and be able to track it in ROS. What I want to talk about now is edge detection. So the goal of edge detection is to actually try to find edges and other types of, and perhaps corners in an image. So why do we want to do this? Well, if we have a picture here, and if this is your standard room, maybe you have some walls, and you have a door on the one wall, and maybe this is again some image here with my poor drawing, but you have your door here in the corner of a room. And well, if you're trying to be a robot to identify and track what's going on, one thing you might want to do is identify these areas where you have edges and corners, and then as you move around in the room, you can then actually track those and figure out where you are by tracking these corners and edges in an image. So the question is now, how do we actually find these types of edges? So, well, it turns out an edge, in essence, is an area that has a high derivative. So if we have our image and we go from something that is white to something that is purple, if this is a solid purple area here, what we can find is that if we look at the derivative of the purple from going from this first area here where there's none to here where there is a lot, we're going to find that there's actually a high derivative in the color space there. So how do we do this when we're processing an image? Well, remember that these are pixels. So if we were to actually take this little area and blow it up more, what we might find is that if we might find that we have an area where we have three pixels where one of them is white, and then maybe the next two are strongly purple. So if we're doing an analysis here in purple, what we might find is that one way to look at this is if we create a mask where we say we have a 1, a 0, and a -1, and multiply this by the purple value here, which may be, 0, 200, 200, what we can find is that if we multiply these together by applying a mask, at this location we can find that we have a strong gradient of 1 times 0, 0 times 200, and -1 times 200, where we get a value of basically 0 plus 0 times 200 plus -1 times 200, and what we get here is this is going to be equal to -200. So now we have a high value along this edge. So this is called mask, and we can apply this to actually compute these types of derivatives on an image. So to see how that works, let's go over here to GIMP, which is basically an image processing system, and here I have a picture of the stadium. And what we see here is that we have all sorts of edges and things in here. And if we go to the filters here, they have this ability to actually just apply one of these matrices here. So if we go into this 1, 0, -1, what you can see is that a lot of these lines, like the field, the lines on the field, show up in the horizontal direction. If we, in contrast to this in the other direction, in the vertical, what you can see is that now we have the lines that are vertical showing up strongly. We can also do things like try to actually, try to find these in both directions by adding this. It turns out that, just adding this in both directions is not as good as some other ones, and there are some classic algorithms that are used to actually find these in 2D. One is called the Sobel detector, and at its base, it's basically a matrix that you're applying to the image with these types of components. And what this is doing is basically, again, this is a mask that you calculate for every pixel. So if you're in this center pixel, you're going to look around at all of the other values around it and basically do the summation of all of them. So again, we can go back to GIMP and we can apply this Sobel detector. So bear with me while I enter these in. And now you can see we find these in multiple directions, okay? So that's fine, but we have, when we do this, when we apply this detector and the Sobel, we're going to apply not just in this one direction, it gets some of both, but we're also going to apply a similar one where we add this in the other direction. And we add these both together to get the Sobel detector. So if we do these, we can actually use this edge detection, and GIMP has this built-in Sobel detector. And you can see we can find all these lines. It comes across a little better if we first actually make it grayscale so that we don't have to deal with all the different color channels. So if we make it gray, and then we look at the Sobel detector, we get the edges here. Now one of the things you'll notice is that there's lots of noise in this area, including in my house where the water is running, but you get lots of noise in the stands because there are lots of little edges there. Well, if we want to get rid of those and just see kind of the main lines, one of the things we can do first is actually apply a blur. So we can apply a Gaussian blur first, where we actually blur out the image to start out with. So now it's, basically we're a little blurry, and the Gaussian blur is a similar similar type of mask that we apply to all the pixels. And then what we can do is, again, apply the Sobel detector here. And now you can see really just the larger edges stand out. There's still some in the crowd that shows up, but we see a lot more of the main ones. So this lets us, detect these types of corner of lines in this image, and also deal with noise by smoothing it. So we can also extend the idea of the edge detectors to actually find corners. So there are a number of corner detectors. So in terms of corner detectors, there are a couple of famous ones are Harris corners and KLT corners. And these types of corner detectors are basically working in a similar way, but instead of finding just edges, they're actually finding points with high derivatives in both directions. So if you look online, you can find more information in the reading section that you need to look at on how to find corners using these types of Harris detectors and the KLT detectors. See you next time. Thanks. So this is where I work when I'm home. I have a treadmill to get my exercise in, a workspace to build robots, and of course, where I've set up to record these videos.